In previous lecture on Wednesday, 6th of October, we gave attention on live demonstration to observe formation of stationary waves transverse type on straight string. We also discussed different ways or styles in which straight string can vibrate when stationary waves are formed over it. These waves are called modes. So we discussed different modes of vibrations of straight string. In each mode, string vibrates naturally and perform free vibrations. What we did, we just plugged the string, disturb it from mean position and left itself. So restoring forces which are developed tries to get the string in again equilibrium position and the string vibrates on its own. Such are called free vibrations. We apply the external force only for to disturb its equilibrium position initially, and then we don't maintain that force to continue its vibrations. Such are called free vibrations. So, in different modes, the string vibrates naturally and the vibrations are free vibrations. But frequency of vibration of the string in different modes has a different value. In fundamental simplest mode, only one loop is formed. So length of string is half the wavelength of stationary waves which are formed. In second mode, immediate higher than the first, over the first, two loops were formed. So entire length L is equal to one wavelength. So earlier the length was lambda by 2. In next mode, the entire length is wavelength lambda, one complete wavelength. So each time value of L changes and hence frequencies with which string vibrates in different modes have different values. Today, we derive equation for frequency of straight string vibrating in different modes. So today's focus is to derive expression for frequencies in different modes of vibrations of the string. I will get my mobile focused close to the board and then we'll continue. So today we are interested to find actual formula for frequency with which the string vibrates when in each mode. So let us begin with, we will consider a uniform string of length L clamped between two rigid support at x is equal to 0 and at x is equal to L. We will apply certain tension so that it will get stretched. So this is position x is equal to 0. This is x equal to L. So effective length of string under vibration will be L. We will apply certain tension. So take the tension over the string is T. This tension we are not changing. We are keeping it constant. So under this tension, we will plug the string and will set it in vibration. In simplest mode, if the string is plugged exactly at the center and released, but we have to plug it perpendicular to its length because particles should vibrate perpendicular to the direction of propagation of progressive wave. Then and then only transverse waves will be created. So for that what we'll do, when you plug it, you have to plug at the center point perpendicular to its length. So progressive waves will travel along the length of the string. Rigid support, what is boundary condition? At rigid supports at 2 fixed ends, node should be formed. This is the basic boundary condition, and hence in simplest mode we will get formation of single loop where it's plugged perpendicular to its head at the center and set itself free. Then you will get only one loop, and due to superimposition of these two stationary waves transverse types will be created. In all these modes, boundary conditions to be satisfied, displacements at the rigid supports is always zero. They will always remain at rest. So nodes should form at both rigid ends. This is only the boundary condition. The lowest frequency of vibration we get in this first case, and thus it's called simplest mode of vibration, labeled as fundamental mode of vibration. So in first case we assume the string is vibrating with its fundamental mode satisfying the conditions formation of nodes at two definite fixed ends, that is rigid support. So if T is tension in the string, if M is mass per unit length of the string, then you know the value of velocity. Last year you have studied this. So velocity of progressive waves will be same as velocity of, because stationary waves do not travel. So here V will be velocity of progressive wave, and it is always equal to square root T by M. If lambda is the wavelength of stationary waves produced in first case, then frequency of vibration, which we call it as fundamental frequency, fundamental mode है उसकी frequency fundamental है, so you know frequency is V upon lambda, so will be 1 upon lambda square root T by M. But here length L is half the wavelength. So we know length is equal to lambda by 2. So lambda will be 2L. Substitute this value in the above expression. We will get N is equal to 1 upon 2L square root T by M. So if I let the string clamp between two rigid fixed points to vibrate with formation of single loop, it will have always the frequency N is equal to 1 upon 2 pi 2L square root T by M. So if L changes, value of N changes. ऐसा भी हो सकता है, L अगर हम लोगों ने कम ज़्यादा की तो for the given mode value of N will change. So this is called fundamental frequency. It is lowest possible frequency with which the straight string between two fixed points can vibrate. Fundamental frequency in this case, let be equation 1. Let us find frequency in the immediate next higher mode, in which we will prevent the center from vibration. We will plug one segment at its center point. Again perpendicular displacement होनी चाहिए. We will get formation of two loops. अगर two loops तैयार हो जाते हैं तो क्या हो जाएगा, देखो क्या हो जाएगा, N will be then lambda, but here stationary waves form have different natures, so their wavelengths will be different. So in this case, N will be lambda 1 for case B, immediate higher mode over the fundamental one where two loops are formed. So frequency of vibration will be then 1 upon lambda. Lambda की value L है, तो 1 by L square root T by M, that will be 2 upon 2L square root T by M. 1 upon 2L square root T by M is nothing but fundamental. So you can write N1 as 2 times N. So if the string is led to vibrate with formation of two loops, it should vibrate with frequency equal to 1 upon L square root T by M. We can prove it as second integral multiple twice the fundamental frequency. Suppose you consider third one. देखो मैं 1 by 1 teach कर रही हूँ. So fundamental frequency in the simplest mode, lowest frequency is 1 upon 2L square root T by M. In immediate higher mode over the first, the frequency is N1, which is 2 times N. Let us proceed further. If the string vibrates with the formation of 3 loops, हो सकता है डिपेंडिंग ऑन द वे यू प्लग द स्ट्रिंग एंड लेट itself free, the string will vibrate accordingly in that particular mode, and from mode to mode situations are different and hence frequency will be different. So frequency कितनी आएगी देखो, ये टोटल लैम्डा बाय लैम्डा 2 हो गया और हाफ, so 1 plus half lambda by 2. So कितना आएगा 3 lambda 2 by 2. So what will happen? L will be 3 by 2 lambda 2. So lambda 2 will be 2L divided by 3. L की वैल्यू निकालने, लैम्डा की निकालनी है, तो कितनी आएगी 2L by 3. So frequency L2 in mode C कितनी आएगी बताओ. स्टैंडर्ड फॉर्मूला क्या है? 1 by lambda square root T by M. अभी 1 by lambda 2 square root T by M. Substitute value of lambda 2. So will be then 1 upon 2L upon 3 square root T by M. With cross multiplication, this 3 will go up. So 3 upon 2L square root T by M, and will be then 3 times N, the fundamental frequency. So if we proceed further this way, for next higher and higher modes, you will get N4. When 4 loops are formed as 4 times N, N5 as 5 times N, and so on. So you get in vibrations of the string fundamental frequency with all its integral multiples 2.5 times n, 3.2 times n, ऐसा नहीं आता है, पूरा इंटीग्रल मल्टीपल आता है. So fundamental frequency with all its integral multiples are present in the vibration of string. String can vibrate with any of these values, with n, with n1, with n2, with n3, and so on. I will give you one example. When the guitarist plays the guitar, एक गिटारिस्ट है, वो गिटार प्ले कर रहा है, वो क्या करता है मालूम है? When if he plugs so that one loop is formed, then his string vibrates with frequency n. अभी जो vibrations of the string है ना, they pass to air molecules in the medium. जो आजू बाजू के सराउंडिंग एयर मोलिक्यूल्स है, उनके यहाँ ये एनर्जी ट्रांसमिट हो जाती है, and a sound wave is created in the surrounding space. If you are there, that sound wave reaches to your ear and you will hear a sound of same frequency n. जितनी फ्रीक्वेंसी स्ट्रिंग की है उतनी ही फ्रीक्वेंसी की साउंड वेव आपको सुनाई देगी. आप सुनते हैं, 1 मिनट, आपको सुनाई देती है. अगर वो सपोज ऐसी तरह स्ट्रिंग प्लग करे कि जहां 2 लूप्स तैयार होते हैं, ही हैज टू डिसाइड। उसने अगर ऐसा प्लगिंग किया कि एक लूप तैयार हो, तो हम लोगों को जो साउंड सुनाई देता है वो एन फ्रीक्वेंसी का है। समटाइम्स ही प्लग्स द स्ट्रिंग व्हेन 2 लूप्स गेट फॉर्म। अभी 2 लूप्स फॉर्म हुए तो हम लोगों को जो साउंड नोट सुनाई देगी उसकी फ्रीक्वेंसी कितनी रहेगी? N1, बिकॉज नाउ ही इज प्लेइंग गिटार स्ट्रिंग इन द सेकंड मोड। So now you will hear the sound of frequency 2 times n. तो नीचे का सा है, ऊपर का। सपोज मैं ब्लैक 4 में सिंगिंग करती हूँ, सा सा, अपर और लोअर आता है ना, वो अष्टक में सा रे ग म, और ऊपर का सा आता है। तो गिटार मेरे को अगर वो असिस्ट कर रहा है और मैंने ऊपर का सा नोट लगाई, तो उसको क्या करना पड़ेगा? उसका प्लगिंग ऐसा होना चाहिए जो 2n वैल्यू वाली साउंड नोट क्रिएट कर सके। तो सेम गिटार है, गिटारिस्ट वो ही है, लेकिन अगर उसने नोट मोड बदला बाय प्लगिंग, क्योंकि हमेशा वो देखो आप लोग, उनका जो प्लगिंग होता है ना, उसका फोर्स डिफरेंट होता है। दे ऑलवेज लेट द स्ट्रिंग टू वाइब्रेट इन डिफरेंट मोड्स एज पर रिक्वायरमेंट। मेरे को वो साथ कर रहा है, गिटार पे ट्यून कर रहा है, तो गिटार और मेरा सुर ये दोनों ट्यूनिंग चाहिए, उनका ट्यून होना चाहिए। तो उसको क्या करना पड़ता है? अगर मैंने ऊपर का सा की नोट लगाई तो ही हैज टू प्ले द स्ट्रिंग विद द फॉर्मेशन ऑफ 2 लूप्स। ऐसा प्लग करना चाहिए उसको कि ऊपर का सा की नोट आएगी, यानी कि 2 टाइम्स n। मैं बोलती हूँ, अब अगर कोई संगीत का जानता है तो उसको समझ में आएगा। लोअर सा, मैं ब्लैक 2 में हूँ, गा रही हूँ, कोई ब्लैक 4 में गाता है, तो ब्लैक 2 का सप्तक और ब्लैक 4 का सप्तक अलग अलग रहता है, वो 7 सुर रहते हैं, सा सा। जब भी वो ऊपर का सा मैं लगाएंगी ना गाना गाते समय, तो गिटारिस्ट हैज टू प्लग हिज स्ट्रिंग in such a way, instead of 1 loop, 2 loops will get formed on that guitar string। 2 loop तैयार होंगे, ऐसा उसको बजाना पड़ेगा। So this is the way the string can plug and can be set in vibrations in different modes. In each mode, the frequency is different. So in general, what can you say? The string can vibrate with all frequencies, fundamental with its integral multiples. So all frequencies, fundamental and all its integral multiple are present in the vibration of straight string। ऐसे हम लोग बोल सकते हैं। कौन से भी फ्रीक्वेंसी से n2, n3, n4, npn, if p number of loops are formed, frequency of sound note created will be n times p, 4p, pn. If 3 loops, frequency will be 3n. If 7 loops, frequency of sound note we hear will be 7 times frequency, fundamental frequency. Fundamental frequency and all its integral multiple are present. Practically, this is expressed in terms of word harmonics। उसको हार्मोनिक्स बोलते हैं। कभी ऐसा नहीं बोला जाता है फंडामेंटल एंड ऑल इट्स मल्टीपल्स आर प्रेजेंट, और हार्मोनिक्स आर प्रेजेंट। सो हार्मोनिक्स इज साइंटिफिक वर्ड, ये साइंटिफिक वर्ड है। एंड lowest frequency, fundamental frequency itself is called first harmonic, and each next integral multiple are called higher harmonic, second harmonic, third harmonic, fourth harmonic. The harmonics having frequencies 2n, 4n, 6n, etc. are called even harmonics. The harmonics giving frequencies 3n, 5n, 7n are called odd harmonics. So even or all are present in the vibration of the straight string. So generally the question is asked. I will read the question. ये question हमेशा पूछा जाता है. Let me know, get the page and I will read it for you. एक मिनट है, मैं पढ़ के बताती हूँ. Show that all harmonics are present in the vibrations of straight string, or draw diagrams showing first two modes of vibrations or first three modes of vibrations of straight string, and derive the formulae for frequencies in each case and draw the conclusion. ऐसे डिफरेंट डिफरेंट क्वेश्चंस, आंसरिंग उसका सेम है लेकिन ये पूछे जाते हैं. सो व्हेन यू टॉक अबाउट साइंटिफिक वर्ड्स लैंग्वेज, the word harmonics is used. All harmonics are present, even or in the vibrations of stretched string. Fundamental frequency is first harmonic, and immediate higher harmonics are labeled as second harmonic, third harmonic, fourth harmonic, twice the fundamental, thrice the fundamental, four times the fundamental are labeled as second, third, fourth, etc. harmonics. So all integral multiples are called harmonics. Abhi all harmonics are present in the string, and during these vibrations, ये मैंने theory आज ले ली. It is point 6.7.5. मैं जो सिखा रही ना वो 6.7.5 on page number 146. ये मैं आज कवर कर रही हूँ. So general formula, if P loops are created over the length of the string, the frequency of that mode will be P times the fundamental or P times the first harmonic. So generally what is preferred when you play or when you plug, the fundamental mode is created. Generally fundamental mode prefer किया जाता है. मैंने बोला है ना आपको. 1 minute. There is network connect problem, network issue, so stay tuned. Stay tuned, don't move.